Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will continue with the UV index, understanding UV index, and we will discuss with some practical examples and how UV index is changed with the different parameters, and why is it important to understand UV index. Because to design the clothing, we must understand what is the strength of the UV in a particular location. Accordingly, we can design our clothing. Like a person in high altitude, where UV index may be much higher than the earth's surface or maybe sea level. So, there we need different types of clothing protection. So, for that we must understand the UV index in depth. So, let us try to see with the practical example. Now, see the example. So, when calculating how strong UV radiation is, scientists only focus the range of wavelength 280 to 400 nanometer. Within that range scientists focus, because that is the wave which comes to the earth. 290 to 400 nanometer, that wavelength are used, since the range of UV pass through the ozone layer, that is the range, that this will be 280. Okay. At that range it is passing through the ozone layer. So, we are not worried about the UV ray of less than that wavelength, because that is absorbed by the ozone layer and does not reach to our body, but in the space above the ozone layer, if we think that their UV index, we must consider everything. Now, typically say 290 is assumed here, and here the 290, its strength is 5. That an arbitrary one strength is giving. 320, its strength is 25, and 400, the strength is 35, because the proportion it's reaching. So, 290's probability of reaching to earth will be less, and 320 and 400 nanometer, they will reach more. Okay. As the wavelength increases, longer wave will penetrate through the ozone layer and will reach more. So, that is why its weightage is giving higher. So, using this preliminary data, that is arbitrary data we have given, to assign the value, to calculate the wavelength for calculation. So, for a different wavelength we have given some assigned some values. So, the made up values could be made accurate, knowing the fact that ozone absorbs longer wave less than the shorter wavelength. So, how intense UV is when it hits the earth surface depending on the wavelength. So, as ozone absorbs longer wave less, so that is why you can see that for longer wave the strength is given. So, that much quantity it is coming to the earth, it is hitting the earth surface. So, longer wave will hit earth surface more than the short wave, because short wave will be absorbed by the ozone layer. Now, hypothetical value is given, actually it may not be exactly identical value, how the different agency calculate the UV index, different agency they calculate the UV index, because this are the hypothetical value. So, some we have given 35, we can give it 40, but the trend here is that as the wavelength increases, the strength of this, that means quantity, strength means here we try to mean it is a quantity of the wave coming to the earth surface. So, that will definitely be higher, but here 5, 10, 5, 25, 35 is given, but someone can give it say 10, 20, 30, that is also possible for certain agencies, but different agency they give, try to give different values, but overall they ultimately will reach to a certain standard value which is representative value. Now, that is given by different agencies, but having the strength weighted with the smaller value for shorter wavelength is accurate. So, that means as I have already mentioned here. So, for shorter wavelength the strength weight we can we are always lower than the longer wavelength. So, that is always true, and that all the agencies they give the lower value, lower strength for shorter wavelength, because the quantity it is reaching to the earth surface is low, because these are absorbed by the ozone layer. So, this is true for all the agencies, they try to calculate the UV index. Now, the shorter wavelengths are absorbed by ozone more than the longer wavelength. So, their strength near the earth surface is weaker. So, that is why the strength is given, that means strength, or you can say quantity which is coming in the earth surface is weaker. So, that is why they are weighted at lower value. And here, so strength is given as it is reaching to the earth surface lower, but their energy of the short wave is very high. These are the weightage actually given based on the energy. Long wave has got low energy. So, energy high means their effect on the human body. So, short waves they actually they are more damaging than the longer wave. So, you can see 400 nanometer has been given weightage depending on the severity, it is 2, whereas 290 nanometer it is giving 17. So, that is that, but effectively as the wavelength increases the severity reduces, that is that. So, that this may vary with the different agencies, but that is true, the trend is true. So, use more initial value, how the skin of human reacts on the radiation. So, that depends on this, based on that weightage is given. When UV index scale was invented, tests were done on human skin at each UV wavelength to see the effects. So, that is initially during the invention of this UV index. So, at each wavelength the effect on the human skin was studied. So, based on that weightage is generated, and scientists found that the shorter wavelengths were more dangerous. So, because the shorter wavelength carries more energy. So, that we have discussed, this wavelength carries more energy. So, they are more dangerous, they actually affect the human body more. So, that is why higher weightage is given here. So, to include this information in calculation, weighing this, so weighting the UV strength at different wavelength is required. So, that we have to weight this UV ray at different wavelength differently. So, this is done using McNeely erythema action spectrum. So, particular relationship we use. So, weight of wavelength is an opposite fashion to the strength value given earlier. So, you can see here. So, the basic thing is strength shows how quantity is reaching, and the weight means what is the energy it is carrying. Like 400 nanometer longer wavelength, it is reaching to the surface at higher quantity, but this wavelength carries less energy, that is least energy, say which is represented by 2, weighted 2. Okay. So, shorter wavelength have been given higher weightage, so more dangerous. So, it gives the severity. So, two aspects are there, that strength means how much quantity is coming, and the weightage means how much dangerous it is. So, like let us go back once again, previous slide. You can see here at 400 nanometer the strength is 35, but its weight is much less. So, if you multiply, the overall effect will be say 70, and at 290 quantity is less, quantity is of reaching its less, but it is dangerous to the 17. So, if you see, if you multiply, we can see it will be total effect on human body will be higher than this 400 nanometer, although it is reaching in less quantity. Okay. So, more dangerous, but lower strength factor, since they are absorbed more on the ozone, and again these values are theoretical, they can be changed little bit, but they are weighted in a accurate fashion. So, basically this the theoretical value 1, 2, 3, the weighted value, but they are weighted accurately because based on the effect, like the weighting here, it depends on the energy which is carrying. Okay. So, these values are correct. So, they are weighted in accurate fashion. Now, try to see here 290 nanometer, strength is 5, weight is 17, and if we multiply, the result comes 18. So, this multiplication, why is it multiplied? Because the quantity which is coming and the strength which is carrying. So, if we multiply, so that means total impact on human body or total impact on the environment. So, this 85 is actually representative of the total impact. So, similarly, for 320 nanometer wavelength, it is 175. So, 25 is the strength and 7 is the weight. So, 175, and 400 nanometer, it is 70. You can see the 320 nanometer, that range, that wavelength, the impact is maximum 170. Major impact will be at the mid range of the wavelength, because their strength is intermediate and weightage is also intermediate, and if you multiply, it will give more impact. So, multiplying this strength of UV by weight and the result will be UV radiations, direct strength, UV radiations direct strength at corresponding wavelength value. So, as I have shown, the for this 320, this is the direct strength at 320 nanometer, 85 is the direct strength of 290 nanometer. So, like that. So, continuing with this example, so data gives the below gives the hypothetical weighting factor for the response of the skin at different wavelengths. Now, the strength at each wavelength from 290 to 400 nanometer, then we add, is summed to represent the overall impact of UV radiation on human skin. So, we just then add. So, 85 was there for, you can see 85 was there for 290 nanometer, 175 was for 320 nanometer, and 400 was there for, sorry, this 70 was there for 400 nanometer. So, these three are added to get the overall impact or overall strength of UV ray in a particular place, 85, 175 and 70. If we add, so total effect of UV within the entire range is 330 for that particular place. Now, so account for how, so this UV ray, So, UV ray will actually change with the cloud cover and elevation. So, 330 which we have assumed, you can go back. So, 330 which we have assumed that without any cloud cover and at the sea level, without any cloud cover and at the sea level. So, if we go at the higher altitude, so at the higher elevation, the UV intensity will increase. So, UV intensity will increase with the altitude, and with the cloud cover the UV intensity will be reduced. So, that these effects we should take into account for our calculation. Now, there is a simplified thumb rule is that. So, it has been determined that for each kilometer above the sea level there is 6% increase in magnitude of UV. So, in the calculation, so 6% means 0.06 is a factor. For every kilometer there will be 0.06 times the added on the UV ray, UV intensity as compared to the sea level. And also we know that the cloud cover absorbs the UV ray, okay, and which reduces the intensity of UV in the earth surface. So, that reduces, and there are different standards or different norms are available for different types of this cloud cover. We can see according to EPA, Environmental Protection Agency, the EPA they have specified. So, what will be the proportion, what will be the factor for different types of cloud cover, like 100% UV transmission is will be there when there is no cloud. So, there the factor will be 1 if there is no cloud. If there is a cloud, so 80% will be transmitted when clouds are spotty. So, that at different spots the clouds are there, then 11% will be absorbed by the cloud, 80% will get transmitted. And for broken clouds it will be 73%, 27% will be, so little bit broken cloud. So, 73% will get transmitted and 27% will be absorbed by the cloud, and completely overcast portion we can see only 31% will get transmitted, but rest 69%, around 70% will be absorbed by the overcast cloud, overcast weather. So, in the cloudy weather if we go out, so the chances of the UV radiation coming to our body will be less. So, depending on the cloud, so cloud situation also has to be incorporated in calculating UV index in a particular location and particular time. So, UV index is not a constant phenomena, constant parameter. So, it is in a particular place, it also gets changed even throughout the at different time of the day. Now, let us give one example. So, let us choose an elevation of 5 kilometers with scattered cloud. So, 5 kilometer, every kilometer there will be 6% increase in the UV ray, then this is the sea level. So, every kilometer, so 1 kilometer 6% increase, 2 kilometer 1, 2 and another 12% increase, 3 kilometer say 18% increase, 4 kilometer 24% increase and 5 kilometer. So, at different, this is earth level. So, at different height, so 5 kilometer, so 30% increase in the intensity, okay, due to the elevation. This is from the sea level, earth surface, and the scattered clouds are there. So, effectively what will happen? So, as we know that there will be 30% increase in the UV ray as compared to the sea level or ground level, okay. And as there is a scattered cloud, so 89% of the ray will penetrate. So, 330 was the total energy. So, then it will be, so multiplying the total UV effect calculated earlier. So, 330 was total UV effect, calculated effect based on the strength and weightage, and elevation and cloud covers are adjusted. So, due to elevation it will be multiplied by 30%, it will be enhanced by 30%, and due to cloud cover it will be multiplied, it will be reduced. So, it will be multiplied by 0.89, 1.3 and multiplied by 0.89. This will be enhanced due to the elevation and reduced due to the cloud cover. So, total effective UV radiation will be calculated accordingly. So, this calculation would look like as the follow. So, 330 multiplied by 1.3 due to the elevation and due to the cloud effect 0.89. So, this will become 381.81. So, again 30% increase due to the elevation would be multiplied as 1.3, since the UV strength is stronger there at the height elevation of 5 kilometer. Now, to finish the calculation, as we know that we have to finally multiplied by 0.04 or divided by the number 25. Now, we have to divide the UV total UV value from the above step by number 25. So, this is actually this 25 is, as we have mentioned, or 0.204, it is by the inventors of the UV index. They have reached that value and round off to the closest whole number. So, that we have to reach. So, let us see. So, according to the EPA, Environmental Protection Agency, the calculation result a number between 0 to 15 or so, different values that can be given. Now, you can see here for this present scenario which we decided, the UV index would be 381.81 that we have got in the last slide we measured, and then we divide by 25. So, ultimately we are getting 15.27 and rounded off to 15. So, that is the UV index at that particular location. So, we can calculate at different position in the earth. So, if it is fully clouded, in that case that total complete overcast, so that we have discussed 31%. So, in that case we have to multiply by 0.31 and say let us do the calculation in a different example. Suppose in the complete overcast, so 330 multiplied by 0.31 due to the overcast, complete overcast situation, and with say after 1 kilometer height, at 1 kilometer height it will be multiplied by 1.06 because 6% increase. So, if we calculate this, we will get that certain UV index divided by 25 and we will then round off that value. So, 15 UV index which we have got in the present calculation, that location where this is extremely dangerous location. So, a person if it is in the scattered cloud condition going 5 kilometer above the earth surface. So, the UV index there will be 15 and it will be very dangerous. So, he or she should protect them with the protective textiles, proper protective gears they should use. Now, the protection measure. So, with the increasing risk, so 0 to 2 is a lowest risk. So, cover head and eye properly because eye is affected by the UV ray quickly. So, we should protect ourselves the eye. 3 to 5 cover head, eyes and use low SPF sunscreen or maybe low UPF clothing, normal clothing will work. 6 to 7 cover head, eyes, body, and we should use little bit higher UPF clothing. 8 to 10. So, there is a guidelines are there, and 11 plus do not go out in normal case, but if you have to go out, so you have to wear, you have to protect yourself with a proper clothing with very high UPF value. Now, the measurement techniques are basically in vitro method for determining the UPF value. So, in vitro method we use the instrumental method and generally used for determining the UPF of fabric. You can see the calculation here. There are with the help of this equation we calculate. Basically, as we know that we have discussed, it is the ratio of UV ray coming with through the fabric and through the air. So, that ratio is there, its value is more than 1. So, these are the different parameters which are given by the instrument, it is measured. In vivo method, where it is generally used for SPF to measure the SPF value for sunscreen, but we can also use for textile material. Main problem here is that we need the human subjects are required. So, main it is based on minimal erythemal doses. So, that means the minimum doses which is actually noticeable changes in skin color, readiness is there. So, calculation is that SPF radiation dose to produce just perceptible erythema under the fabric cover, and here radiation dose to produce just perceptible erythema to the uncovered skin, that we have already discussed earlier also. And there are different standards like European standard EN 13758, another European standard EN 137.512 in 2003, it has been modified, Australian and New Zealand standard, AATCC, ASTM standard. So, there are different standards available. Accordingly, we have to test the UV protection value. ASTM D660307, these are the different standards available. Now, let us see the effect of various textile parameters. What are the different textile parameter which actually controls the UPF of fabric. So, there are different factors through which we can adjust the UPF of a fabric. So, these are the different factors like material related factor. This we have discussed in last sessions, earlier session, the chemistry. So, for in the fabric, so UPF of cotton, viscose, rayon and linen usually lower. So, the normal cellulose fiber they have lower UPF and than the UPF of nylon, wool and silk. So, they are for high UPF value. So, polyester provides usually high UPF. So, if you need inherent UPF, so we can use polyester or maybe wool and nylon are better than the cotton, viscose. So, accordingly we can select the raw material, porosity, weight and thickness. So, UPF generally increases with the decreasing porosity. That means, if the fabric is compact, in that case we get higher UPF. So, for compact fabric we can get the higher UPF value, and increasing the fabric weight, higher weight or higher thickness generally provide the higher UPF value. Darker shade gives higher UPF value. If we use the UV absorbers, UPF value is increased. Now, after stretching, like knitted fabric that gets stretched. So, after stretching due to opening up of the pore size in between the thread, so that will allow the UV ray to pass through. So, UPF decreases under stretch, and when the fabric becomes wet, the UPF decreases. Okay. So, because through the water it gets changes the refractive index, and the UV ray can pass through the water easily. And in washing it is observed that washing increases for cotton fabric, washing increases the UPF. It has nothing to do with the any chemical changes and all this, it is basically structural changes. When the washing cotton fabric is washed, it's actually it gets shrinkage, and it becomes very compact, relatively compact, and pore size is reduced. That is why only the UPF increases, otherwise there is no point of increasing. In rather after repeated washing, the other material, okay, they it is observed that UPF value decreases. So, if you see the washing for cotton, UPF increases mainly due to the shrinkage character, shrinkage of that. Now, you can see here. So, number of cycle it is there, it is shown, it is increasing, but it is mainly due to the shrinkage of cotton fabric, and fabrics become more compact. So, UPF of clothing gets modified during laundering process. Basically, if we use the some finish, the UV protective finishes, that gets removed if it is not proper. So, with the laundering that gets removed, and effectively the UPF should reduce, but in case of the study report shows that it is increasing, but it is mainly due to the shrinkage of the fabric. So, most fabrics shrink after laundering, thus the open area of fabric reduces, which in turn improves the UPF, otherwise there is no reason. Now, so the raw materials we have used. So, mainly for fabric parameters, you can see fabric geometrical parameter, there are primary parameters and secondary parameter. For weave, yarn count and thread density. So, it depends on the weave pattern, like in plain weave we can have very compact structure. So, for plain weave the UPF will be higher than the others like satin or twill. Yarn count, for keeping all other parameters constant, thread density constant, if we increase the yarn count, like if we make the yarn thicker, it will result higher UPF, because it will block the inter-yarn space. The thread density basically it will if we increase the thread density, the UPF value will increase. Now, coming to the secondary parameters. So, all the secondary parameters are dependent on this primary parameter, like fabric cover factor, it is dependent on the yarn count and thread density, fabric porosity, fabric mass, fabric thickness, and fabric mass density, and yarn crimp. Yarn crimp also affects. If the yarn crimp is high, that means there will be a compact structure, Now, the fiber type we have also discussed earlier in detail. Now, you can see in short there are, we can divide a normal fiber into three classifications. Normal apparel grade fiber, it is a group 1 polyester, group 2 wool, silk, nylon, and group 3 cotton and yarn. So, UPF value increases from the group 3 to group 1. For commodity fibers, polyester having highest UPF and cotton is shows the lowest UPF. Now, you can see the UV absorption property is strongly dependent on the chemical structure. So, polyester has got this type of structure, conjugated aromatic system of the polymeric chain. So, for this it absorbs UV ray more effective in UV absorption. Here it absorbs more. So, it is more effective in UV absorption due to this conjugated aromatic system. And for cotton or cellulosic fiber, no double bond is there in the chemical structure, have a low intrinsic UV absorption capacity, and so it is relatively lower UV protection. But natural pectins, okay, pigments, wax in natural cellulose fiber acts as UV absorber. So, for natural cotton it is a little bit higher UV resistance than the washed or scoured cotton, scoured or bleached cotton, and cotton has got relatively higher UPF than cellulose fiber, that is viscose, due to the natural wax and pectins. So, let us see the effects of yarn linear density. Now, here yarn linear density in text, as the linear density increases keeping other parameters constant. So, the diameter is increasing. So, this is the ends per inch, thread density is kept constant. This is the lower diameter yarn. So, say it is a 20 tex, and if we are making it coarser, so if you see it is coarser yarn. So, here the space in between the threads are much smaller, here space is higher. So, it allows the UV ray to pass through quickly at the higher quantity. Now, again we can see here at different count in weft yarn, weft count versus UPF. So, in English count it is as it becomes finer weft yarn. So, UPF value reduces. So, due to the more and more opening. Now, effect of weave and thread density. So, as the thread density increases, so pix per centimeter increases, the fabric becomes compact. So, UPF is increased, and we can see for plain weave it is observed that the UPF is very high, and for matte it is low, because it also depends on the actual opening of the, here it is a 3 up 1 down twill, it is showing highest. It is not necessarily the same trend, this is actually reported by one researcher, but this trend may not be true for other structures, but effectively plane weave can generate very high compact structure because of the higher interlacement. So, plane weave generally gives higher this UPF, but if we can have compact structure even with the satin, if we can lay the yarns properly, we can achieve very high UPF, but after repeated use laundering, the threads may get distorted and which ultimately affect the UPF value. Now, see the effect of fabric weave and fabric tightness. Here is the UPF. So, satin, you can see the satin here it is showing the higher UPF value, because in satin this is higher UPF value, because we can lay the yarns properly in the surface, whereas in the plane weave it is showing as per this study. So, if as the fabric tightness increases, the UPF increases, but in case of the plane weave it is showing lowest, because in the interlacement point there will be opening, but this may not be true always. After repeated use, this satin and twill may get distorted, but plain fabric will have certain structural integrity. So, twill is used for high UPF, and this trend is not universal trend, that can, this is for a particular set of fabric, that can also change depending on the type of yarn and all other aspects we have to take into consideration. We can see here cover factor and UPF, that is correlated. As the cover factor is increasing, so UPF increases, that is as we know, it is a very straightforward relationship. Now, the effect of yarn volume porosity. So, which is important? So, volume porosity if it increases, so yarn volume porosity, that means interfiber space is there in the yarn. So, if it is porous, the yarn in the yarn, so that will be the that will allow the UV ray to pass through, and here yarn volume porosity means here that the percentage of pore volume in the volume of the woven fabric with different types of pores. So, the pores are generated by the 3D volumes, if we calculate the total volume. So, that depends shape of the volume, type of volume will be depending on the different types of weave. Now, Vf is the that pore volume is expressed by the relationship 100 minus Vf multiplied by 100. This is expressed in terms of percentage. So, Vf is the fabric volume fraction and PV is the volume porosity and Vy is the volume of the yarn. So, if you see that it is a volume of yarn divided by the volume of fabric. So, in a particular yarn, particular volume of yarn, how much fabric, how much volume is covered by the or occupied by the yarn. So, that is the it is not it is a little bit different from the our cover factor. Here we are talking about the volume porosity. So, how much volume it is covered. So, if the volume porosity is increased, then the UPF value reduces. That means, it is how much porous the structure is. So, if the structure is more porous, so that will allow the UV ray to pass through easily and UPF value reduces. Now, here the fabric weight and UV transmission, we can see typically if the fabric weight increases, that depends on the different types of fabric. It's there is no straight relationship. So, basically the UPF actually depends on the UV transmission, depends on the proportion of the pore area. So, through which the UV transmission takes place. Similarly, for thickness also, higher thickness does not mean the more UV blocking. So, it depends on the structure. So, color effect, as we know, dark color will give the highest UPF. So, this is the transmission. So, if you see the black color, transmission is very low. Okay. So, typically 0.5% or less than that. So, where in black color we can achieve up to 256 UPF value, and red color and undyed fabric, natural fabric will have very low UPF value. So, effect on the spectral transmission of same initial fabric. So, fabric is undyed fabric is same and it is dyed with 7 different colors. So, we can see as the depth increases, it will give the enhanced UPF value. So, additives also have effects. So, dye, pigment, delustrant, optical brightener, UV absorbers, this we have already discussed in detail when we discuss the science of all these additives and how are they reacting with the UV ray. This we have discussed, but in additive on the textile material has got effect. The techniques to incorporate these additives on the textile structure is actually this can be added during the fiber or yarn manufacturing. At the polymer level we can add this additive on the fabric surface by special treatment. Now, let us see the effect of concentration of dye stuff and UV absorber. As the dye stuff concentration increases, the UPF increases. So, if you can see the concentration of UV absorber, if it is increasing, so UV absorbers concentration, so dye 0% dye stuff, okay, this is there, and 0.5% dye stuff and 2% dye stuff. So, here it is there, you can see the UV transmission, okay, transmittance is reduced as the UV absorber condition increases, and with the 2% dye stuff, 0% dye stuff, you can see even with the increase in concentration, it is as it is reducing. So, with the 0% dye stuff, so transmittance is very high, and as the dye stuff percent increases, the transmittance reduces. So, there are different other factors. Laundering, it has effect, it affects the UPF value, moisture content and wetness affect, swelling also affects. So, if it swells, the fiber swells, then they will block the pores and the UPF may increase. Linear and aerial stretch, so any stretch will change the pore structure. At different layer, if we increase the layer, the UPF value will increase, and depending on the design of the fabric. So, we will stop here, and we have seen the different factors on which the UPF of textile material changes or depends, and in the next session we will discuss the different research studies through fabric engineering to create the fabric with a particular UPF value. Till then, thank you.